Hey, hi everyone. Welcome to my channel. So we are going to discuss about the algorithm. Okay. So in today's lecture, I will explain about the time complexity, which is one of the main part of our algorithm. Okay, let's start. So let's assume person A and person B. He wrote an algorithm A1 and B wrote an algorithm A2. Okay. Now, how we can determine whether A1 is better compared to A2 or A2 is better compared to A1? Okay. We need some unit. See, whatever we measure, like if we measure petrol, right? We need liter. If we measure distance, we need kilometer. So like this, we have some unit for everything. Now, how we can determine two algorithm, which one is better? So to determine that, we have a two kind of complexity. One is called time complexity and second one is called space complexity. Okay. So what is time complexity? Time complexity is something which is determine how much time it is required to execute your algorithm. And what is space complexity? So space complexity is that how much memory it consumes when your algorithm runs. Now space complexity means it is kind of depends on RAM. Okay, and time complexity means you can assume in second or millisecond, something like that. Now which is more important? Yeah, I know both are important when you are talking about the algorithm, but which is more important? See, by paying more money, you can buy more RAM. Okay. So if some algorithm is taking a little more RAM, but it is taking very less time, it will be preferable. Okay. So that's why today's class, we are going to talk about the time complexity. Now, how we can measure a time complexity? We have three ways or three units, you can say. One is called big O notation. Second one is called big omega notation, and third one is called big theta notation. Okay, in this three notation we can determine the time complexity. Okay, now let's see one by one. So big O. So big O is called upper bound. Now what is upper bound? Let us assume this is your home. Okay, and this is your university. Okay, and this is the road which you can start every day and you can reach to your university. Let us assume if I ask you how much time it is required to reach from your home to your university, you say let us assume 15 minutes. Okay, now I gave you two conditions. Let us assume some traffics are there, or due to some signals are there, some red signal and all. So what is the maximum time it will take to reach from your house to university? You say whatever this scenario, in 30 minutes I will reach. Okay, now I gave you one more scenario, that what is the minimum time it will take? Let us assume everything is clear, road is clear, no signal is there, everything is green. What is the minimum time it is required to reach your home to university? You say 10 minutes. So can you see, now we got three different time, right? 10 minutes, 30 minutes and 15 minutes. Okay, 10 minutes is called best case. 15 minutes, which is called average case, and 30 minutes is called worst case. Means whatever the scenario, within 30 minutes you will reach. Okay, now let assume which is more important out of these three. Obviously three is has their own importance, but see, worst case means whatever the scenario, within that time I will reach. Means whatever the how much big the input is, your algorithm can finish within that time. So in algorithm also we can determine three types of complexity: best case, average case, and worst case. Best case means what is the minimum time it will take your algorithm to find out the output. It is called best case. What is the regular time it takes? That is average case. In if your input is very big or some other condition, what is the maximum time your algorithm will take to complete it? That is called worst case. Okay. Now big O is the upper bound. So what do you mean by upper bound? Upper bound means it is the maximum time. Also you can say this is for use to worst case. If you want to find out the worst case, you can use the big O complexity. See, if I draw a graph, this is for n, this is for time, okay, and this is the n0 initial, and there are two one. So this is the Fn, this is the Gn. Okay, Gn means this is the maximum. Okay, so I can write a equation: Fn will be less or equal to C multiplied by Gn. Okay. Okay, so now what is this equation? It is saying that maximum this amount of time it will require. So Fn value will always be less than C multiplied by Gn. Okay, what is a C? C is a constant which is positive number. Okay, so this is the equation for big O. Now let's see big omega. What is big omega? Big omega is determine the lower bound, or you can also say it is used for best case. Okay, so how it will be the graph here? So same n0, it is n, this is for t, this is fn, and this is the gn. So it determines what is the minimum time it required to finish the algorithm. Okay, so what will be the equation? Fn will be greater or equal to C multiplied by Gn. Okay, means this is the minimum time it required to finish its job. Okay, this is big omega. Now big theta. What is big theta? Big theta is determine the average case, right? So its graph will be okay, and you can put one at middle. So C1 in of Gn, this middle one is Fn, C2 of Gn. Means what it means that we will have a equation Fn, okay, whose value will be greater or equal to C2 of Gn, and one more Fn will be there whose value will be less or equal to C1 of Gn. So it is kind of satisfying both the cases. If it is in between, then we can say Fn will be theta of Gn. Okay, clear? So this is the three way we can determine the complexity. If you have any doubt, please let me know in the comment section. So today's lecture is up to this. Next lecture we'll see what is small o, small omega, and small theta. Okay, thank you.